Okay, so we are on 1.1 day 2 today. This is a protractor. Okay, that's what it is called. You notice there are from left to right, the numbers increase on the outside, and from right to left, they increase on the inside. Okay, you read these. This one's already placed for you, but if you notice, they have a line. Most of them will have a line right here through 0, and they will have a line through 90. And where they intersect, right here, you put it on the vertex of the angle. So you put it on the ray, the bottom ray, and the vertex of the angle, and then you can measure it. Okay? I don't know, have you ever used a protractor? You guys? Okay. So when you look at it, this ray down here is called the initial ray, because angles actually show movement. Did you know that? It shows the first position where it was, and then it moves, and you see the second position. So it's actually 2 positions of one ray. So if you think about this, you can think of it like this is the first position, and then it moved again and ended up here, and moved it again and ended up here. Does that make sense? So when you read it, you have to be kind of careful, and you do have to use a few brain cells because sometimes we don't like to use those. When I'm going from A to B, just here, I'm on the outside, I'm about, what do you think, 47, 46? What do you think?
46. No,
47.
47? Okay. On the outside, I'm 47, but on the inside, I'd be 147, or 137. Nope, 133. I'd be 133. This angle is obviously not 133, is it? No. So you use the part that you need. It might be the inside and it might be the outside. You have to decide, okay? Now, when I go from A all the way to C, what's that angle? 105. And when I go from A to D, it is what? 130. Are you sure it's not 50?
It's 130.
It's 130. Okay. Even though it lines up at 50, but you guys know? Oh, 1 second. I need to pause this. This is 130, and the other angle is 150. Does anybody know what's special about 130 and 150 if I put them together?
180.
It's 180. What's special about 180?
It's the whole.
It's the whole.
thing.
It's the whole protractor, right?
Yeah.
Okay. Do you know what the angles are called? The 2 angles that add up to 180 are called? Does anyone know?
No.
Obtuse.
Well, obtuse is bigger than 90 degrees. Acute is smaller than 90 degrees. And we'll go over this. I just wondered if any of you know. They're called complementary. I'm sorry, supplementary. Supplementary. Got them wrong. 2 that equal 90 are complementary. And we'll go over that next week. But I just thought, well, maybe you guys might know. Okay, so we have that information. We read this exactly like a ruler. Couldn't we do this exactly like a ruler? Like subtract 2 things to find in between? Yes. It is essentially a measurement device for an angle, so a ruler for angles. Okay? So what is BEC? What's the measure of BEC?
BC. So 47.
Exactly what you said. 105 minus 47. You just automatically did that because we'd been doing it with the ruler, right? So we better subtract, right? So I get 58 degrees. You guys get 58 degrees?
I don't know.
You better check me, because I can carry wrong like the rest of you. Don't forget your degree symbol. No.
Yes.
That's a no-no.
Why?
No.
Why?
Ever heard if you don't use it, you lose it? Yep. We can do basic subtraction. There will be times we'll use calculators, but we will work on always improving our basic addition, subtraction, multiplication, division. Sorry. Okay, so did you guys check my math? 58?
It is.
Okay. So, next one is what is AEC? Well, I think we already did AEC, didn't we? AEC? What? 105. You guys get to do BED. Is in your way at all?
This is all mixed up.
What?
This is my computer in your way at all? Okay. Did you get A3?
Yep, I did.
Okay. And I would assume you all did 130 minus 47, right?
Yes,
Yeah.
indeed.
Okay. Questions? You think we're good on this one? Solid on it?
Yeah.
Okay. This we're not going to write this down. It's not on your notes. It's just the protractor postulate. It just says that if it fits on a protractor, it's between 0 and 180 degrees. That's it. Pretty much it. Okay, here's your if-then statement. You have angle addition postulate on there, yes?
Mm-hmm.
And you have if and the picture. So then you have to fill in the then. But don't fill it in yet because I want to talk about it. How many angles do you see on this picture?
3.
There's 3. 2 small and a big, yes?
Mm-hmm.
So if I took ABD and I added it to DBC, so 2 little ones, I get the what? The whole big one. So that's exactly what this says. It says then the measure of ABD, angle ABD, plus the measure of angle DBC is equal to the measure of angle ABC. That just basically says the little angle plus the little angle equals the what? The big angle. If there was one big angle cut into 8 parts, you just add up all 8 to get the big. Yes?
Yes.
That's all it says. And again, postulates are something we can't prove because it's kind of like a does statement. If I have 2 parts of a whole, if I add those 2 parts together, do I get the whole? Yes. Did you fill in your then on your notes?
Oh.
It says
Okay.
then. I know, I have to remind you to take notes. It's okay. Okay, we good? Just watching my time. Okay, so I have angle, there's my picture. Yes? If this was in the book, you would draw that picture on your paper. It doesn't have to be perfect, it just has to be something that you can make your brain manipulate. Okay? Do not draw in my book. Okay, so it says if the measure of angle SPR is 60 degrees, so we probably should write a what? A 60. And the measure of SPQ is 119. So SPQ, that's the whole thing, yeah?
Mm-hmm.
So 119. So what is the measure of QPR?
Probably 60.
No.
No.
Subtract it.
Just subtract it. 119 minus 60.
59
So we get 59. 59 what?
degrees.
Degrees. Don't forget your degree. Because again, if you don't put your degree on your homework, where are you not going to put it when it counts?
In the test.
On the test. Am I good?
Yes.
Okay, now this is a real problem. You will have application problems, story problems, word problems, whatever you want to call them. I had a teacher one time that he would get furious unless you called it an application problem. If you cannot apply what I'm teaching you, why am I teaching it to you? Correct? How many times a day do you hear somebody, when am I going to use this in real life? Really? And it's always that snotty too, isn't it? Right here. There's a real life situation right in front of you and it's geometry. So, a lighting designer is finalizing the lighting plan for an upcoming production. The spotlight can rotate 25 degrees to the left and to the right. So this center line is center. The light can rotate 25 degrees center to 25 degrees center. Got it? Okay. So, the beam of light forms a 22 degree angle. So they have the light on there, correct?
Mm-hmm.
So if I were to divide this light, because when it rotates to its 25 degrees, it still has light on the other side of the center of the spotlight, correct?
Mm-hmm.
So in the middle of it, how much is each side of it? How much is here, here, and here? 11?
I guess.
Well, if it says 22, yeah, so it'd be 11. Okay. So, can the designer spotlight hit every object? Okay. Well, I'm not worried about the door and the rug. Why?
Because they're already getting hit with the
No,
light.
they're right in the middle. That's not a big deal. I'm worried about the chair and the
Table.
table. So we need to do some math to figure it out. And I'm going to tell you your answer to this is going to be written words. But do we have to do some math to get to our written words? Yes. Okay, so how do we need to go about doing this?
So, adding.
We've got this whole angle from the table to the chair is 74. I don't know if that's going to help us at all, right? No, I guess it could. I just thought about a way we could solve it, but I'm not going to tell you. I know this from the door to the chair is 57. So what could I figure out?
57 minus 22 or 25.
Well, 22 is just this beam in here. I mean, you could do 57 minus 22, but that doesn't. Oh, I guess that would tell me right in here. Is that what you wanted? So he says if we take 57 minus the 22, that should give us
35.
right in here. So you're saying that's 35, right?
Yeah.
Okay, so this is 35. Okay. So we know that the spotlight can swivel 25. Like the center can go 25. But when I swivel past center, I still have some light over here, don't I?
Yeah.
How much light do I have over there? 11 degrees, don't I? So I can do 25 plus 11 gives me what? 36. Can I get there?
Yeah.
Yeah, because it's what? 30. It's 35, and this is 36.
Yeah.
Yeah? Okay. So this is a star. Okay, got it. Now we got to see if we can get to the table. So what do we need to figure out there?
Subtract 11 to 22.
Subtract
11.
22 from the 74.
I think we'll do the 22 to 74 is going to get us this little piece right there. Because that's what we need, right?
Yeah.
Because if we do the 22 from the, what did you say?
11. I guess.
Well, that all, the 22 and the 11 are the same. It's all the spotlight information. So it's like it's the same information. Okay, so let's take this 22 because that's this much minus, well, but is that going to give me what I need?
It's 52.
Well, you'd have to subtract 57 from
57 from 74. Okay, so I got 74 minus 57. So 17. Yes?
Yeah.
Okay, so it's 17. So that means in here is 17. So I have 22 from center, right? So it'd be 22 plus 17.
Yeah.
So 22 plus 17 is 39. Can I hit it?
No.
No. Because what did we say our magic number was?
36.
36. So this is sad. We're sad. Okay. So we've answered the question with some random math, but have we relayed my answer to the teacher?
No.
No. So we need to think of, I can write 2 sentences that relays my answer and why. So I want you to try to do it, and I'm going to do it, and we can compare them. Okay? You can tell me the information first and then answer the question, or you can answer the question and explain why. Does that make sense? Okay, so the information you do know is from here to here was 35, right? And from here to here was 39. And our total spotlight coverage is 36. So does it have to include that information? Yeah. Okay, so you guys try. I'll be writing. You be writing. It's all good. Okay, you can keep writing. I'm just going to tell you what I write. I wrote the spotlight can cover 36 degrees of the stage left and right. Is that what we found total?
Mm-hmm.
Okay. The chair is 35 degrees left and the table is 39 degrees right. The spotlight will reach the chair but not the table. Now, Peyton, you're unnecessary. Okay, so did I explain my reasoning? Did I explain all the math, all my jumbled work? Yes. This is also a skill, guys. I don't care if you're going to talk about math or whatever, but when you're an adult and you have a job, are you going to have to relay information to somebody?
Yes.
Yes. And you don't want it too wordy. I don't think I was very wordy. I said it can cover 36 degrees left and right. The chair is 35 degrees left. The table is 39 degrees right. And so it can reach the chair but not the table. Could you vision that in your head without the picture?
Yeah.
With my statement, you can picture the chair over here, table over here. I can reach the chair. You couldn't do that?
That's about all the chair and table.
Huh?
So that's about all the chair and table.
Yeah, but that's all you need, right? Because the rug and the door, we don't care about because why?
They're
It's
not
gonna
the
hit
problem.
That's not the problem area, is it? When I'm doing a play, I'm not concerned about the thing right in the center, am I? I'm worried about, can people see this over here on the left or the right? The center, everybody can see. Okay? So the bottom question, we're not going to work out any work, but I want to ask you, if I increased it for the angle to be 33 degrees. If I could rotate it 33 degrees to the left and to the right, it would definitely reach, wouldn't it? Because we'd have our 11 plus our 33 and we get 44. And I would definitely get that 39 in there, wouldn't I?
Yeah.
Okay. So just if you can get that to go a little bit more, and actually 25 degrees to 33 degrees probably isn't a whole lot, is it? So just loosen the bolt a little, not too much. You don't want to like hit somebody on the head or anything, but okay. So I put my pen away and I shouldn't have. So the next slide was if we wanted to take the time, but I don't want to take the time. Okay, so this information is just already on there for you. I'm going to go over it. We're going to talk about it a little bit, and then we have some examples to do. We're almost done here. Okay, so congruent segments and congruent angles. We need to know what the word congruent means. Can you guys sit up, like engage or something? Thank you. Okay, so congruent. Does anybody know what congruent means?
The same.
The same. Okay. And I'm glad you didn't say equal. Okay? Because objects are congruent, measurements are the same, are equal. Objects are congruent, measurements are equal. So these tables are all congruent. But their dimensions, 2 by 6, are equal. I had object and I had what? Measurements. So people will say, well, they're the same thing. Well, kind of, but I don't know. We know they have the same measurements, but do I know the measurements with congruent? No, I just know that they're the same, okay? The symbol for congruent is right here. It's kind of little. It is an equal sign with a tilde. It's called a tilde on top, just squiggly, okay? You will need to use it when you are talking about congruent objects. You will use that symbol. So when we want to say two segments are congruent, we put dashes, the little tick marks on them. So these two are congruent because they each have one tick mark. These are congruent because they have how many? 2. And if they had 3, there would be 3. I can have 2 congruent objects. I can have 30 congruent objects. It doesn't matter. If I give you this lined polygon and I have 10 of the lines are 1 tick and 5 of the lines are 2 ticks and 6 of the lines are 3 ticks, that means those lines that have the tick marks that match are congruent. Does that make sense? Riley, give him a nudge. You sit up. That's why I don't let people lay down. Okay. Angles, we don't have tick marks, we have little arcs. These 2 angles are congruent because they have 1 little arc. These 2 are because they have how many? 2. If I have more, they'd have 3 or 4 or whatever. Got it? Okay. That's all that means. Here are some statements. They're kind of does statements. They're called. I have different properties. Reflexive property. If AB is congruent to AB, is a segment congruent to itself?
Yeah.
Yes. Is an angle congruent to itself? Yes. Okay. Symmetric property. AB is congruent to CD, so that means that CD is congruent to AB. Duh. Left to right, right to left. Okay? Next one is called transitive property. Remember you guys did the distributive property, the transitive property, the commutative property. Remember those in algebra? Transitive property says if this thing's equal to that and that's equal to another, then those are equal. Yes? So, if AB is congruent to CD and CD is congruent to EF, that means that AB is congruent to EF. If angle A is congruent to angle B and angle B is congruent to angle C, that means that A is congruent to C. We know those things, correct? So, I didn't put them in there. I just wanted to remind ourselves of it. Okay, so we have the measure of XWZ is 127. What is YWV? Okay, so the whole thing, right? XWZ, the whole thing is 127, yes? So how are we going to find just the middle part, right? Subtract what? Say that again?
127 by 32.
Well, we can get 127 minus how many 32s?
64.
Two of them. How do we know that both of those angles are 32?
Because they're congruent.
How do you know they're congruent?
Because they got one dash.
They got one arc each, right? Okay, so you could put 2 times 32, or you could put 32, or you could write 64. It's better to write 32 plus 32 and then the 64, so I know where you got 64. Because sometimes 32 plus 32 would be like 63, because our brains like to do that, right? So if you tell me where you got it, I won't worry that you don't know what you're doing. Make sense? Okay, so let's subtract. We get 63 degrees. Okay, so the measure of YWV is 63 degrees. The next one I want you to do on your own.
I have messages in the office for Peyton Decker, Haley Hoover, Isaiah Dalcotter, and Eliza Wallenberg. Please stop in the office after the bell rings.
Okay, I got 41.5. Did you get 41.5?
I got 80.
I got 73.
Why do you have to divide?
Because there's you want ROQ, yes?
Yeah.
So you want right here? Yep. So if I want right there, if I take 114 minus 31, I get both of those two congruent angles, don't I?
Yeah.
So all I have to do is divide it by
2.
2. Okay? So 41.5.
Well, at least I got half of it.
Yep. Okay, so quick listen to me, please. On the bottom of here, you are going to do this as part of your homework. So you have the book assignment that is on Classroom. Yep, right there. Good job. Thank you. You have the book assignment that's on Classroom, right? And this. So when you're turning it in, take a picture of your book assignment and then that. Okay? You can take multiple pictures. Just keep taking them till you're done. Okay?